In this video, I am going to discuss about arc welding process, polarity in arc welding process, arc initiation techniques, arc welding electrodes. We have consumable electrode and non-consumable electrodes, type of flux coating on the arc welding electrodes. So arc welding process. Arc welding is a fusion welding process. In arc welding process, the heat required for welding is obtained from the electric arc created between the electrode and the workpiece. See, in an arc welding process, the source of heat is electricity, high ampere and low voltage. That's a very important point. In an arc welding process, the source of heat for welding process is electricity, high amperage and low voltage. In arc welding process, DC or AC power source will be used. So in an arc welding process, an electric arc that is created between the electrode and the workpiece to be joined. When high current passes through an air gap from one conductor to another, it produces very intense concentrated heat in the form of spark. See, that spark having a temperature of 3600 degrees Celsius, which is used to melt the base metal that has been undergoing welding process. See, the arc is maintained by uniformly moving the electrode towards the workpiece and hence keeping a constant gap between the electrode and workpiece. So during arc welding process, the electrode should be moving towards the workpiece in order to maintain a constant gap between the electrode and the workpiece. And also, the same time, the electrode is moving along a desired line of welding. So on solidification, this forms a joint between two parent metals. See, this is a figure of arc welding process. So once more, arc welding is a fusion welding process. In arc welding process, source of heat is electricity or which have high amperage and low voltage. So in arc welding process, an electric arc is created between the electrode and the workpiece. When high current is passing through the air gap between two conductors, there will be high intense source of concentrated heat will be produced in the form of spark. See, that spark have a temperature of 3600 degrees Celsius. That temperature is used to melt the metal to be jointed. So during every arc welding process, the electrode is moving towards the workpiece in order to maintain a constant gap, and also the electron is moving along the weld line. So this is the figure of the arc welding process. Every arc welding process consists of arc welding machine. The main purpose of the welding machine is providing welding current and the filler material. So this is the workpiece to be jointed, and this is the electrode, and this is electrode holder. Okay. Next one is polarity in DC welding. In arc welding process, we are using either AC, DC or AC current. Okay. So next one is the polarity in DC welding. It's very important, polarity in DC welding. See, importance of polarity in welding. In DC welding, 2/3 of heat is liberated from positive end and 1/3 from the negative end. See, in any DC welding process, 2/3 of heat is in any DC welding process, 2/3 of heat is liberated from positive end and 1/3 from the negative end. 2/3 means 70% of heat is liberated from positive end and 30% heat from negative end. Okay. There are two types of polarity: straight polarity or electrode negative, DCEN, reverse polarity or electrode positive, DCEP. So first one, straight polarity. In straight polarity, electrode is connected to negative terminal and workpiece is connected to positive terminal of the power source. That's an important point. In straight polarity, electrode is connected to negative terminal and workpiece is connected to positive terminal of the power source. In straight polarity, 70% heat at work. Why? Workpiece is connected to positive terminal and electrode is connected to negative terminal. So 30% of the heat at the electrode. 70% heat at the work and 30% heat at the electrode. Straight polarity also called direct current electrode negative. So electrode is at the negative, connected at the negative. So that's a straight polarity. So in straight polarity, electrode is connected to negative and workpiece is connected to positive. Then reverse polarity. In reverse polarity, electrode is connected to positive and workpiece is connected to negative terminal of the power source. It is also called direct current electrode positive. 70% of heat at electrode and 30% heat at workpiece. So that's the difference between straight polarity and reverse polarities. Straight polarity is used for welding with bare light coated electrodes, welding thicker section. Why we are using thicker section? 70% heat at the workpiece. And reverse polarity is used for welding non-ferrous metal, welding of cast iron, welding with heavy and super heavily coated electrode, welding of thin parts. So this is the application of straight polarity and reverse polarity. So this polarity is very important one. Okay. So next one, arc initiation. So arc എങ്ങനെയാണ് welding arc എങ്ങനെയാണ് initiate ചെയ്യുന്നത്? Okay. Arc is initiated by providing a conducting path between the electrode and the job, or by ionizing the gap between the two. There are two methods for initiating an arc, welding arc. Providing a conducting path between the electrode and the job. Otherwise, ionizing the gap between the two, electrode and the job. These are the two methods for arc initiation in welding, arc welding. So there are different methods for arc initiation. First one, a momentarily touching the electrode with the job and taking away. So this is the electrode and this is the workpiece. A momentarily touching the electrode with the job and taking away, the arc will be created. Second one, by scratching the electrode with the job. By scratching the electrode with the job, the welding arc will be initiated. By keeping a steel wool between electrode and job. See, a steel wool will be created. That means providing a conductive path. A steel wool will be placed between the electrode and the workpiece and the arc will be initiated. Then, in automatic welding machine, arc can be initiated with the help of a carbon rod. So, automatic welding machines, arc initiate a carbon rod use ചെയ്തിട്ടാണ്. So, carbon rod that will be touching the electrode and the workpiece within a second of time and the arc will be initiated. So, these are the methods for initiating the arc in arc welding process. So next one is arc welding electrodes. So what is the importance of electrode in arc welding process? See, the welding arc is created between the electrode and the workpiece. Okay. So electrodes are classified into two types: consumable electrode and non-consumable electrodes. So what is the difference between consumable electrode and non-consumable electrodes? Consumable electrode means when the electric arc struck between the electrode and workpiece, the electrode consumes, electrode get melt and the metal is transferred to the molten weld pool. That type of electrode is known as consumable electrodes. When we are using consumable electrode, no separate filler material is used. No separate filler material is used. So non-consumable electrode means electrode is not consuming during welding process. Electrode is not melting during welding process. In that case of non-consumable electrode, we have to use separate filler material. Okay. So consumable electrode. Consumable electrode consumes during welding operation. When the arc between the electrode and job struck, the end of the electrode start melting and transfer to the job as droplets. The electrode itself acts as a filler material. So consumable electrode means during welding process consumable electrode get consumes. When the electric arc struck between the end of the consumable electrode and the workpiece, the electrode get melt, material is transferred into molten weld pool. See, when we are using a consumable electrode, there is no need to use separate filler material. See, these consumable electrodes are classified into two types, bare electrode and coated electrodes. So first of all, bare electrodes. Bare electrode consists of metal or alloy wire without flux coating on them. The metal passes from electrode to work are exposed to oxygen and nitrogen in the surrounding air. This causes the formation of non-metallic constituents which are trapped in the rapidly solidifying weld metal and thereby decrease the strength and ductility. See, in the case of bare electrodes, there is no flux coating over the electrodes. As the metal that is transferred to the molten weld pool, it is exposed to surrounding atmosphere. When it is exposed to surrounding atmosphere, the metal absorbs oxygen and nitrogen and it will form non-metallic constituents and that will be trapped in the rapidly solidifying weld metal. It will decrease the strength and ductility of weld bead. Then in coated electrodes, second classification is a coated electrodes. In coated electrode, there is a flux coating over the electrodes. So what's the importance of flux coating? This flux undergoing chemical reaction and produce a shielding gas that will protect the molten weld pool, spark and this melting electrodes. So the shielding gas, the flux will produce the shielding gas. Flux also produce slag. Slag have less weight compared to molten material and the slag will float over the molten material and it will separate the molten material from surrounding atmosphere. The slag also acts as a cleaning agent. It will absorb impurities from the molten material and slag reduce the oxidation. So that's the importance of flux coated electrode. When we are using a flux coated electrode, there is no additional flux there is not need to add the additional flux separately. Okay. In coated electrode, there is a flux coating on the electrode. Coated electrodes, flux coated, are used to prevent the formation of oxides and help to form slag. That's the important thing. Due to flux coating, the molten metal is not exposed to oxygen and nitrogen in the atmosphere, resulting in strong bond. Commonly used in flux are asbestos, mica, silica, etc. Okay. So depending upon the coating, electrodes are again classified into four types, depending upon coating factor. See, depending upon the coating factor, consumable electrodes are classified into flux coated consumable electrodes are classified into light coated electrode, medium coated electrode, heavily coated electrode, super heavily coated electrodes. So what is coating factor? Coating factor is the ratio of coating diameter to coating wire diameter. So coating diameter to coating wire diameter means, suppose this is the electrode. See, this is the coating diameter and this is the wire diameter. Okay, this is flux coating diameter and this is the wire diameter of the electrodes. So coating factor equal to coating diameter divided by coating wire diameter. So depending upon this coating factor, consumable flux coated electrodes are classified into light coated electrodes, coating factor 1.25 to 1.3. Medium coated electrodes, coating factor 1.4 to 1.5. Heavily coated electrode, coating factor 1.6 to 2.2. Super heavily coated electrode, coating factor above 2.2. See, these are the classification based on the coating factor. So, based on the coating factor, consumable electrodes are classified into light coated electrode, medium coated electrode, heavily coated electrode and super heavily coated electrodes. Okay. Types of flux coating on the arc welding electrodes. What are the different types of flux coating over the arc welding electrode? See, cellulosic, the flux coating may be cellulosic, cellulose wood, pulp and floor. Rectile, coating based on titanium dioxide. Coating based on titanium dioxide is known as rectile. Basic or hydrogen controlled electrode. Coating based on calcium carbonate or calcium fluoride. Iron powder electrode. Coating contain iron powder. So these are the basic flux coating, commonly using flux coating on the arc welding electrodes. See, the electrodes are usually manufactured in two lengths, 350 mm and 450 mm. See, the arc welding electrodes are usually manufactured in 350 mm and 450 mm. Okay. So in this video, I have discussed about arc welding process, then polarity in arc welding process, arc initiation method, different type of electrode in arc welding process, and flux coating over the arc welding process, arc welding electrodes. Okay, thank you.